Today we're learning how to simplify radicals. I know I've got this when I can use the product and quotient rules to simplify square roots, simplify radicals containing variables, and simplify higher roots, higher than square roots. So key vocabulary are perfect squares. So I want you to pause the video and write these down. These are going to be extremely valuable to you throughout the rest of the year. So where I'm getting all these numbers is 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, and so on. Those are all the most common perfect squares, but clearly there are an infinite number of perfect squares, but these are the main ones that we will be using. Okay, so product rule for square roots. If the square root of A and the square root of B are real numbers, then you can multiply those together. You can only multiply radicands with other radicands and outside numbers with other outside numbers. Okay, so here we go. So we're going to simplify the following. Now, you notice it does not say approximate. So none of these are going to be, you're not going to use your calculator. It's not that I'm not allowing you, you are just not going to. You will get it wrong, okay? So the square root of 40, you have to think, obviously it's not a perfect square, but it does have a factor that's a perfect square, which is 4. Right, so I can break 40 up as the square root of 4 times the square root of 10, and I know that the square root of 4 is 2, so I get 2 square root of 10. The square root of 63, again, it's not a perfect square, but it does have a factor that's a perfect square, which would be 9. And then I can multiply that to the square root of 7. So the square root of 9 is 3, and then I've got the square root of 7. Now the square root of 15, none of its factors are perfect squares, so I cannot simplify it. So that it's already simplified. So the same thing for quotient. So if I'm dividing the square root of A over B, I can break that up into the square root of A over the square root of B. So here's some problems. Okay, the square root of 36 over the square root of 49. You do one of them at a time, so you get 6 over 7. The square root of 3 over the square root of 16, I can't simplify the square root of 3, but I can break it up, and then the square root of 16 is 4. All right, now we're going to try one with a variable. So assume that the variable represents a positive number. All right, what is the square root of 36? 6. Now, you ask yourself when you're doing the square root of x to the 7th, remember how I said the square root of x to the 6th is x cubed because you're multiplying x cubed times x cubed, and that would give you x to the 6th. Well, clearly nothing here would give you x to the 7th. So this is what you do. This index number you assume is a 2, right? Because it's a square root. So this is how you do variables. You say 2 can go into 7 how many times? 3 times. With how many left over? 1. So again, you ask yourself, how many times can it go into it? You put that number on the outside, and any left over, any remainders are go on the inside, because you would have 2 can go into 7 3 times with 1 left over. So you go ahead and try these. And then your answers are at the bottom. Let me know if you're struggling with any of those. All right, number 2. Now we're going to do more with variables. Okay, 2 can go into 5 how many times? 2 with 1 left over. So you would write it like that. Okay, so I'm going to break 18, the square root of 18 over the square root of x squared. So you can't leave radicals in the bottom at all. We'll get to that more in a little bit, but how many times can 2 go into 2? 1. And I'm going to put the absolute value, and then I'll show you why in a second. Okay, 18. What's a factor that's a perfect square? This can be written as the square root of 9 times the square root of 2, right? Which would give me 3 square root of 2 over the absolute value of x. Now, any time that you go from an even index to an odd exponent to an even exponent, you're going to take the absolute value. That ensures that the number here is a positive number. Okay, because you can't have an negative number under the radical. Okay, so again, anytime you go from an even exponent to an odd exponent on a variable, you must take the absolute value of that variable to ensure the radicand is positive. You need to write that down. It's not from odd to even, it's just from even to odd. Okay, so let's do C. All right, how many times can 2 go into 3? 1 time with 1 left over. How many times can 2 go into 10? 5 times with none left over. Now we look and see you're going from an even to an odd exponent, so I only take the absolute value on that y. So those are my final answers. Okay, 2b, let's try this. All right, 90, I can break into 9 times 10, right? So what's the square root of 9? 3, and I can't do anything with the 10, so I leave it under the radical. Okay, 2 can go into 3 1 time with 1 left over. 2 can go into 4 2 times with none left over. 2 can go into 5 2 times with 1 left over. Now, am I going from even to odd on any of this? No, so that's my final answer. Okay, 45 I can break up into 9 times 5. So the square root of 9 is 3. And I can't do anything with the 5, so I'll leave it under the radical. 2 can go into 4 2 times with none left over. 2 can go into 5 2 times with 1 left over. And 2 can go into 6 3 times with none left over. And on the C, I'm going from an even to an odd exponent, so I need to take the absolute variable. And the reason that I'm saying 2, just to remind you, is because the index number here is assumed to be a 2. Versus F, look at that, okay? We're talking about a 4. So this is one of those nth roots that we were talking about. So it's the 4th root. All right, what times itself 4 times is going to give me negative 81? Negative 3. Now, as far as the variables, you would say 4 can go into 12 3 times with none left over. 4 can go into 9 2 times with 1 left over. And 4 can go into 8 2 times with none left over. Are you going from an even to an odd exponent on anything because it's an even index number? Yes, the A, so you take the absolute value of that. All right. Now, here's some for you to do, try. And those are your answers. Those are your final answers. All right, so now we're talking about product rules and quotient rules. So again, the same thing that we did before. This is just for any nth root. Okay, so now we're going to simplify the cube root of 40. Well, 40, there's nothing times itself 3 times that's going to give you 40. So you have to think, what are factors of 40 that are perfect cubes? So 8 is a perfect cube. What is the cube root of 8? 2. So you're at 2 times the cube root of 5 is your final answer. Okay, so this, I can break up the cube root of 27 over the cube root of 64, 3 over 4. Okay, now these are getting a little harder because the root is getting a little bit bigger. Okay, so the fourth root of 162, I can break into the fourth root of 81 times the fourth root of 2. The fourth root of 81 is 3 times the, sorry, hang on, 3 times the fourth root of 2 would be your answer. And then the fifth root of 128, again, that's pretty tough. So we're going to do the fifth root of 32 times the fifth root of 4, because 32 times 4 is 128, and the fifth root of 32 is 2. Those are kind of tough. Okay, but go ahead and try these and see if you can get them. And you should have gotten that because 500 can be broken into 125 times 4. And so it'd be 5 times the cube root of 4. And then 5 times 5 times 5 times 5 is 625. And 6 times 6 times 6 times 6 is 1296. So that would have been your answers. Okay, here's some extra practice. Go ahead and pause it and see if you can get it. And those are your answers. So I know I've got this when I can use the product and quotient rules to simplify square roots, simplify radicals containing variables, and simplify higher square roots. How would you use the product rule for square roots to simplify the square root of 45? You would use the square root of 9 times the square root of 5, which is 3 square root of 5. How would you use the quotient rule for square roots to simplify the cube root of 5 over 8? The cube root of 5 over the cube root of 8, and then you can simplify the cube root of 8 to 2.